Welcome or welcome back. And C squared in this lesson, we'll talk about Pythagorean theorem that goes with a right triangle, and a right triangle is a triangle that has a right angle, like the one you see here in the picture. This is a right triangle. In a right triangle, the hypotenuse is the longest side and is on opposite side of the right angle. The other two sides, the adjacent sides, are called legs. And this is the property that goes with this Pythagorean theorem. Leg 1 square plus leg 2 square equals the hypotenuse square. In this case, we can use this form. We can identify the leg 1 AC, leg 2 BC, and the hypotenuse AB. And a very famous formula is this one: A squared plus B squared equals C squared. And this is, in fact, the theorem in a right triangle. The sum of the square of the lengths of the legs is equal to the square of the length of the hypotenuse. So let's see how we use that here. And again, I'm going to use that famous one, like I said, A squared plus B squared equals C squared. Remember, A, B, and C, A and B are the legs. You can switch them in this case, right? If you want to say A is 12, that's okay. Doesn't matter. But be sure C is the hypotenuse, in this case x. So we have here 5 squared plus 12 squared equal x squared. 5 squared is 25, 12 squared is 144 equals x squared. So x squared equals 169, and for finding x we need to take square root. And since we talk about geometry here, no reason to put plus and minus. This x will be square root of 169, which is 13. And that's it in this case. That is the length of the hypotenuse ABX in this case. You will see it later. I'm going to talk about these wonderful numbers. But let's first take a look at another example. And in this one, you notice I can call this one A. Then I have this to call this one B. And remember, the one on the opposite side is of the right angle is C. So we have A squared plus B squared equals C squared. So we have 6 squared plus x squared equals 10 squared. So we're going to have here 36 plus x squared equals 100. In order to find x here, we need to subtract 36. So a little bit different than the other one, than the first example. And we have here x squared equal 64. And x will be square root of 64, which is 8. And I'll put this group of numbers here, this triple, 6, 8, and 10. Also, it's a good one to remember. And in fact, if you notice, that is what I put on this slide. These numbers are called Pythagorean triple. And this number go with this rule: A squared plus B squared equals C squared. All of this. Now, if you notice, this one is an easy one to remember. 3, 4, and 5. But I would like to emphasize that's the only one that works like that. 3, 4, and 5. That's it. The next one you see here is nothing else than the first one, the first set of 3 numbers, 3, 4, and 5, times by 2. So can I get another one? Yeah, times by 3 you have 9, 12, and 15. Times by 4 you have what? 12, 16, and 20. So if you can see a number like this, then your job is going to be a lot easier. We had this one today, 5, 12, and 13. This is multiplied by 2, and obviously you can do the same. Multiply by 3, 15, 36, 39. Multiply by 4, you can do it. And the same for more Pythagorean triples. You see them here, right? So I will be honest with you, I remember this one easy, 3, 4, 5, and 6, 8, 10. Those are pretty easy. 5, 12, and 13, it's a good one. And this one also, 8, 15, and 17 are pretty decent Pythagorean triple you can remember and will help you to move with your problem faster. So now let's move to the next part of the lesson. And I said here, you can use Pythagorean theorem to determine whether a triangle is a right triangle given the measure of all three sides. And that's what I said here. If a squared plus b squared equals c squared, then the triangle ABC is a right triangle. So this is the converse of the previous theorem. We switch the hypothesis and the conclusion. And you see it here, if the sum of the square of the lengths of the shortest side of the triangle is equal to the square of the longest side, then the triangle is a right triangle. But I would like to emphasize here, shorter sides, longer side. So that's the way you want to see in your problem. So let's see this example where we have three sides, and I will go from with this order: 13, 84, and 85. Okay, now these one are the shorter and this one is the longest. Okay, so now we have a squared plus b squared. Is that equal with c squared? If that works, then we have a right triangle. So let's see, 13 squared plus 84 squared, is that equal with 85 squared? So the 13 squared, I think it's 169, but let me grab a calculator. Yeah, that is 169. For sure I'm going to need a calculator for 84 squared, which is 7056. And let's see what 85 squared is. Again, you see I put that question mark on top of the equals. We're checking if this statement is good. And this is 7225. So one more step. We're going to add these two number on the left side. And 169 plus 7056. Let me do it one more time. 169 plus 7056. That's exactly 7225. So now we notice these two guys are the same. I can put a check mark. We verify that a squared plus b squared equals c squared. So now we know this is a right triangle. Yes, the triangle is a right triangle. When is not a right triangle? Whenever you do not get a true statement, then you do not have a right triangle. With this converse of the Pythagorean theorem, we can move to more theorems about triangles, and this is one of them, which says if a squared plus b squared is greater than c squared, then we have an acute triangle. Let's see what the theorem says. If the sum of the square of the lengths of the shortest side, so again you want to arrange them from the shortest to longer, is greater than the square of the longest side, then the triangle is an acute triangle. So remember this theorem. So let's see how that looks. But first of all, let's see the second theorem. This one, very similar, but now look at here. The sum of the square of the lengths of the shortest sides is less than the square of the longest side, then the triangle is an obtuse triangle. Okay, so these are the two theorems, and we're going to use them in my next example. Again, now we have 6, 11, and 14. And obviously A, B, C. Probably I should have done this on the previous problem. And we have a squared plus b squared. And then I'm going to put here on the other side c squared, which is 14 squared. I'm not going to put any sign because I want to see what sign we have. And we have here 36 plus 121 and 14 squared is 196. And 36 plus 121 is 157. And this is 196. So obviously here we notice less, less, less. A squared plus b squared is less than c squared. So therefore, because we have this statement, you remember, this will be an obtuse triangle. Okay. Sometimes you may have some points given in a rectangular grid, and you want to determine whether these points can be the vertices of a triangle, like in this case. If so, determine if the triangle is acute, right, or obtuse. Justify your answer, right? So probably, to be honest with you, the first thing I'll do, I'll plot the points like I did here, and you'll see it if they form a triangle or not. But the idea here is you can use inequality in a triangle and see by figuring out the lengths of AB, BC, and AC, if you'll see if they accomplish to be a triangle. I will show you in a moment what that is. But let's find how long AB is. And since we have the picture, I think it's better to, instead of using the distance formula, we're going to use Pythagorean Theorem. So I'm going to go with AB, and if you notice, this is 2 here, this is 4. I can use A squared plus B squared equals C squared. The first time, I'm going to use it 3 times. And A and B are 2 and 4. We can switch them, it really doesn't matter. And that will be AB squared. So we have 4 plus 16 equals AB squared. So we're going to have AB squared equal 4 plus 16, 20. So I'm going to need that also because we need to determine if it's acute, right, or obtuse. So AB will be square root of 20, but I'm going to need also AB squared later. Okay, very similar. I'm going to move and get BC. A squared plus B squared equals C squared. So don't get confused, even though we use the same A squared plus B squared equals C squared, in this case is different, right? This is 1, this is 1, 2, 3, 4, 5. So we have 1 squared plus 5 squared equals BC squared. And we have here 1 plus 25 equals BC squared. So BC squared will be 26, and BC obviously will be square root of 26. And like I said, we can evaluate, and probably I'm going to do that also. So let's go now to the last one, which is obviously is AC, which is this gentleman. We have 1, 2, 3, and 1, 2, 3, 4, 5, 6, 7. So we have A squared plus B squared equals C squared. The third time. And we have 3 squared plus 7 squared equals AC squared. So we have 9 plus 49 equals AC squared. So AC squared will be 58, right? 58. And AC will be square root of 58. So first of all, let's also do some evaluation here. Square root of 58, I'm going to grab a calculator. It is, let me change the mode of my calculator. Okay, so square root of 58 is 7.61. I'm gonna stay with just 2 decimal. I think it's good enough. Let's go to BCE to get an evaluation. Square root of 26. And that is 5.1, I will say, like something like that. And let's go to the last one, AB, which is square root of 20. It should be around 4 something. 4.47. So that is the idea of determining if these points can be a triangle. You want to take a look and you know, add these two guys, 4.4 plus 4.47 plus 5.1. Is that greater than 7.61? It is, right? So that works. Then you're gonna do 4.47 plus 7.61. Is that greater than 5.1? It is, right? So it's accomplished. And then the last thing, right? 5.1 plus 7.61. Is that greater than 4.47? By using these inequalities and check them, we know now, yes, it is a triangle. But of course, like I said, if you have graph paper, plot the points, you'll see it's a triangle. In fact, if you take a look, you can see even that this one, it looks like an obtuse triangle. But how do I check that? Let me show you how you check that. You look here and say, hey, which one is the shortest? Obviously, is this square root of 20. So we square that one, we're gonna get 20, right? So we're gonna have a square, right, which is 20, plus b square. Now, which one is the next one? It's this 26, right? And then let's take a look to c squared, 58, right? We have here 46 and 58. What will be the relationship between these two numbers? This is less, right? So what kind of triangle we have if a squared plus b squared, the shortest side, the sum of the shortest side is less than c squared? This is going to be an obtuse, again, triangle. Now we justify our answer. Let me erase this. So this is a justification that you may need it. Yeah, just plotting the points and look into the picture is helpful, but if you need to justify, this is the math you need to do. I said here next that it's very useful in real life to know Pythagorean Theorem. It's very used. So the size of a computer monitor is the length of its diagonal. You want to buy a 19-inch monitor that has a height of 11 inches. What is the width of the monitor? Round to the nearest tenth of an inch. Okay, so let's see. A picture will be helpful. This is the monitor you're gonna buy. You know that 19 inches. That whenever you hit that, when you buy something like a TV or a computer, that is the diagonal. That's the way they measure. And the height is 11. So now we can find this x, the width of the monitor. Sometimes you need that, right? To see, hey, is that something I can fit in my room, I guess. So a squared plus b squared equals c squared. Remember, a and b are the legs. You can interchange them. You can switch them. That's not a problem. Be sure the c is the hypotenuse. This is a right angle, by the way. Okay, and we have 11 squared plus x squared equal 19 squared. 11 squared, it's 121 plus x squared equal 19 square. And that will be 361. 361. We're going to subtract 121 on both sides because we want to find x, right? So we have x squared equals 240. So x will be square root of 240. Again, we don't need the plus and minus. And that will be 15 point, rounded to the nearest tenth of an inch, 15.5. The width is 15.5 inches. Okay, and like I said, that might be something that you need to see if you can fit in your room. And my last part of the lesson, we're gonna take a look to these special cases of when you can use Pythagorean Theorem. And also you can see on my channel what we call special triangle, a very good way. But let's say you never heard about special triangle and you want to solve something like that. So in this example here, you want to find this x. But you notice this is 6. And this will be 6 also because these two are congruent. So that's something very important you want to take a look at in your geometry class. Okay. So basically, how do you find x now? Again, you do a squared plus b squared equals c squared. So we're going to have 6 squared because remember, the legs are a and b's. The hypotenuse is c. So we have 6 squared plus 6 squared equals c squared. So we have here 36 plus 36 equals x squared. Probably I should have put x here just to be consistent with my previous problems. So we have x squared equals 72. So x will be square root of 72. It's very important to know how to simplify radical. This one will be square root of 36 times 2. And that will be 6 square root of 2. Like I said in another lesson where I discuss about these special triangles, that will be a shortcut. X is 6 square root of 2. Now, if you take a look at the second problem, very similar. It's going to be a very useful triangle that I'm going to discuss in a different lesson. Okay, but let's take a look. This is 6 here. I notice also these two segments are congruent. So this will be 6. So we have what we call an isosceles triangle. That means this angle base is 60, and which means this vertex base is also 60, right? Because the sum of the interior angle of a triangle, the sum of the measure of the interior angle of triangles is 180. So in fact, what we have here, and it's good to remember that, is a equilateral triangle. Okay, so the picture, nobody says that, but you can see it in the picture, and that is useful. Why? Because now you know this altitude, this height of the triangle, it's also a median. It breaks this in half, so each one will be 3. So now I know I have a lot of things on the picture there. I can make it simpler now. And I can find x, because this is 3, this is 6, and I can find this x by using a squared plus b squared equals c squared. So again, Pythagorean Theorem. And we're gonna have here, here again, be careful, now x is one of the legs, so we have x squared plus 3 squared equals 6 squared. So we're gonna have x squared plus 9 equals 36. I'm gonna subtract 9. X squared will be 36 minus 9. That will be 27. And I'm gonna take square root of 27. And now how do I simplify this one? It's good to remember 27 is what? 9 times 3, 9 being a perfect square. And then we have square root of 9. That will be 3. 3 square root of 3. Yeah, there is a pattern here. Maybe you already noticed. If you did not notice, you can watch my lesson on my YouTube channel. But that is in this case for this problem, for this example. And the last problem for today, so these last two problems were like some extension of Pythagorean theorem, right? So let's take a look. Example, find the length of CD, these gentlemen right here, right? If AB is 3, okay, this is 3, this is 3. If you remember, there is a pattern I just discussed. If you remember, that's good. If not, you're gonna do a squared plus b squared equals c squared. This will be 3 square root of 2. Again, you can do exactly what I did on the other problem. Now, this one will be 3 square root of 2 also. And you know what? Let's use the Pythagorean theorem here to find the length of CD. So again, I'm going to draw that triangle one more time. Hopefully it's a decent triangle. Yeah, it's not exactly, it's not accurate, but these two legs are congruent. So this is an isosceles right triangle. You can hear that name also. And we need to find this x here, which is CD. So we're going to have a square plus b square equal c square. So we're going to have 3 square root of 2. You see I use parentheses here. I will suggest you to do it. Plus 3 square root of 2 square equals that x square. Now the question is, what is this guy? 3 square root of 2 square. That means 3 square root of 2 times 3 square root of 2. And if we multiply two radical, we multiply these two guys. 9, and the radical we have square root of 2 times square root of 2. Some people may say square root of 4, which is fine. I personally say 2. So we get 18 here. So we have here 18. The next guy is also 18. Don't have to do one more time, equals x squared. 18 plus 18, that will be 36. And x squared 36, that means x is square root of 36. And that will be 6. Yes, CD is 6. Now some of you may say, I can see the pattern here. This is 6, this was 3, right? Yeah, it's double. Is that the case all the time? Yeah, you can try, change the number and see, you will see the same thing. Now, you can move further and get, this is 6, and you can get this gentleman. That will be 6 square root of 2. I will let you try to do that and eventually put a comment on my YouTube channel if I'm wrong or if I'm okay. If you enjoy this lesson, don't forget to click the like button and come back on C Square for more help. Thank you.